Hello explorers and welcome to another video. Last time in this Linux video with Linux from scratch, we built a lot of math libraries and we also set up our shadow environment for our password management. And today we're going to continue with building the actual compiler that is going to be used by the system. So this is GCC that we're going to compile. And this is a large one that will take a lot of time. So let's start off by doing a little bit of a setup. And as you see here, I've upgraded my environment. I'm still using the same Ubuntu environment, but I've logged in with SSH, so I can actually copy paste things, which makes it a little bit faster to go through. This case we have here, it looks at the actual machine name and sees if we have an architecture that is 64 bits, and in this case I have. And in that case we run a sed command that will change lib64 to lib in this Linux 64 file over here, and also rename it to original so we have a copy of it if we want to go back. So that's the first thing we do. Next up, we will run a command called to remove the old link to GCC that we used during the compilation of the other things, just to not confuse the system on this, and it will be replaced when we are installing the new GCC. Then we will create a build directory and enter into that. We will configure our system using sed, and with a lot of parameters we will prefix where we want to put this into /usr. We want to enable the languages C and C++. We want to disable multi-lib, so we don't want to build multiple, both the 64 bytes versions and 32 bytes. We want to disable the bootstrap process. We don't want to run that again. We want to disable libmpx, and that switch the memory protection extensions, so we don't build those. And we want to use the system clib that we built earlier, so we get the right libraries into this GCC. So we will do that make and this configuration, then we will run the make command, and this will take some time, so I will be back when it actually has built. And I'm back! New day and new opportunity. And it took a long while. This was, I believe, 92 SBUs, so it's a very long process to get this to compile with all the tests. But the tests are crucial because this is the compiler we want to use to build our system. So this is the main thing that we will use to build everything else. So it's important to get this one right. And in order to run the test, we need to change the U limit to 32,768. And this is a stack that we will change because the stack size is too small to actually fit the full test. So that's why we are changing that up. And they also suggest to remove one test that is not performing well and will cause a problem when we actually run our test suite. So fine, we will remove that one. Then they want us to run all the tests as nobodies. So no, this is actually telling the system that we want to be the user. We will change this directory to be owned by nobody, and only root can do that. So let's see if we can do sudo here. Sudo command is not found. Yeah, it changed from root to nobody. Yeah, so it didn't actually give us any problem there. And then we can, let's see here, I need to copy the next one. Let's see. the right window. Then we want to, as nobody, switch over to bin bash and run with the current path that we have in our context. So we will set the path for this context that we want to run in, and we want to run make with -k, and -k is, let's see here, that we shouldn't stop for errors, I believe, and then we should run this check. And this will also take some time, so I will start this now, and I will get back when this is done. And we are back. We have run all the tests, and there have been some failures, and there is actually a command to get a test summary, and you can actually run a grep on that in order to only get the summations. So let's see if it gets us here. So they want us to take this and then compare that to a run that they did. It should not vastly differ from their results. And actually, they had some unexpected failures on lib standard C that we don't have. So that it's even better than their results. We had the same expected failures here, none unexpected. So I think we had one unexpected failure on the, let's see, GCC summary. So, and they also had one unexpected there. So unexpected failures, I think we need to look at. And the same goes for this summary up here. And then we have a lot of expected failures. Yeah, so I believe that we had the same amount of unexpected failures, expected failures, pretty much that they had. So I think we should see this as an success. So we have a working compiler. The next thing we need to run is make install, of course. So we put that into our system. And then we need to do some symlinks. This install process should not take that long, even though the compiler is quite large. Putting things into the system after you have built them is usually fast. So let's see here, we need to do a symlink to the CPP or the C++ directory in USR bin to our library folder. We also need to do a little bit of a switch over that CC is the same as GCC if you are running CC instead of GCC. Then we want to install some BFD plugins. Don't really know what that is. Add compatibility symlink to enable building programs with link time optimization. Okay, LTO. So we install that, and then we will create a symlink from one place to another. So it will link this long link time optimization plugin to their rightful place. After that, we need to create this little dummy program that we did before. We want to run the compiler on that dummy program and get an output. We do an elf read of that and see that we actually got a valid program out. And then we have all these different greps here. So we will want to look for that the different control libraries are actually working correctly. So the output should be this. Depending on my machine, the output might differ slightly, but they are exactly the same as in the manual. And then we want to look at this. Oh, it's the same. So that should get the output of the different include directories that we have. So we actually have the right paths in our system. And the important part here is that none of these paths are linking to tools that we used to build our GCC before. if we have tools anywhere in these paths, then we have built the GCC not against the system, but against our old compiler that we use to bootstrap this process. So tools should be nowhere in these strings. So we will search for the next here, and it will look for the different search dirs. We don't have a tools directory in this either. And we also want to see that we have the right libc, and it's the same output there, so it's also the correct. And we want to look that you actually found the correct dynamic linker. So after we have done that, we can remove all the files we created. We want to make a new directory for, let's see, push. Okay, we want to push a misplaced file. That's interesting. So we had a Python file that have happened to ended up in the wrong location. So that's weird that the compiler actually has those kind of flaws. So now we have built the compiler, so let's go on to build a few more. We want to have bzip. Bzip is another of those libraries that will compress things on your system. So this bzip2 is not that large, but it needs a bit of work. First off, we want to go into this directory, and then we want to run a patch. So we, copy paste is awkward for me. I don't do that. Haven't done that through the series before. So patch np1, so we get some output and interactive, and we want to start from 2 folders down, and we want to look for the bzip and then dash install docs patch. So it's a patch that will install the documentation for this package. So that's a weird patch to have. And we also want to run this command to ensure that all symlinks are relative. And that seems like a good thing. We also want to ensure that the man pages are installed to the correct location. So we want to run that command. So it moved the man pages to share man. Why? The man pages should be in just the man directory, I believe. Then we want to make run the make file with libz bzip2so. Prepare bzip for compilation, and this will cause bzip2 to be built using a different make file. In this case, the make file lib bz2so file, which creates a dynamic libbz2so library and links the bz2 utils against it. Okay, so we want to make the dynamic library so we can reuse this in other use cases. So we will run this, and after we run that, we actually want to clean up after each other, which is strange. You usually don't build something and then clean it up right after, but it didn't clean up the library up here that we built. It cleaned up some other files. And then we want to run make again to build the actual tool for the system, and no failures there. So now we need to do make install into the USR directory. So we will get this this compress library, and then we want to run a bunch of different small scripts here. So we first off here copied bzip2 shared into bzip2 in our bin directory. We copied some of these libraries that we built before into the lib directory. We also linked up this library, so we have 1.0 of that in the same directory, and we removed the bzip and some of the other pre-built that we had before in the system. We removed those, and then we will copy these bzip over to the bin directory, so we have all of those in the bin instead for USR bin. So that's the change over there. Next up, we will need to do the package config. So now we have another package to compress things, and now we need to have a configuration of the package. So let's see, I'll take that up, go in, we need to configure it. So we run this little command here to configure. So we set the prefix to USR. We want to use the internal glib. So this uses the internal, the glibc that we built earlier. We use that instead of an external version. Well, wait a minute, internal version of glib, because the external version is not available. Okay, so we haven't built glib, we have built glibc, but not glib. So in this case, we want to use the glib from this package. And we want to disable host tool, and this disables the creation of an undecided hard link to the package program. Okay, so we don't want to create that. And we also want to specify what the documentation directory should be. So let's run that. So this package config is a tool for passing the include path and library paths to build tools during the configuration and makefile execution. So this is some kind of tooling that you are using during your build process to actually find out the different paths that you are required to use in your build process. So I guess that some of the later packages that we want to install requires this in order to actually link against the different libraries you have in your system. So this should be pretty fast to build as well. So we run a make after that configuration. It will build all these glib libraries that you see here. So this is the internal glib that it builds up, and then it will build the actual package config. And there it was done. Let's make a little check and see that everything works fine. It passes all 30 tests, and we will make an install, so we will have that package in our system as well. Now comes the next package, and this is Ncurses. And Ncurses is a little bit of an interesting package. It's the package that we use to make some different outputs in text for menus and such. So we will unpackage that and unpack that. Then we need to run a sed command, not make install. And we need to copy as well. So we don't want to install the static libraries that is not handled by this configure. So we will remove the libtool install. And then we will need to prepare the Ncurses, and that's a long command. And in this case, I can go through the different flags, and you will see those after the configuration here. We have the prefix, as we did before, into USR. We have defined a specific man directory, so where the manual should be. We specify with shared, so with shared libraries. So this with shared here. Then without debug, so no debug dependencies or debug information. Without normal, so without normal. This switch disables building and installing most static libraries. Okay, so we will not install those. Enable PC files, and this installs the PC files for the package config. So this will add those files that the package config that we installed earlier requires to find different paths for Ncurses, because Ncurses will be built, or Ncurses libs will be used by different software. And we will also enable WIDEC, and this will add the wide character libraries, so we can actually use, for instance, Chinese characters and so on. So these more verbose characters that is not in the 8-bit locales. So we have done that, so let's run make. So I can talk a little bit about Ncurses. This is a library for terminal independent handling of character screens. So for instance, if we have a menu in our kernel build and we need to figure out which different settings we need to set, or which how to configure it, we can actually move through that menu using the Ncurses library that will build these different dialogues in text that you can use in your Linux system. So it's something for the command line, but it's creating these interactive menus. So it's a very nice little package. So let's make install that. So we have that in our system. And after that, we need to move the shared libraries into the lib directory where they are expected to reside, because they were in USR lib before. And because of that they have been moved one symlink to a non-existent file, we need to recreate it. So we need to actually add one of those files back into the USR lib because it's required there. So that's why. Let's see. And then we have some more fixes here. Many applications still expect the linker to be able to find non-wide character Ncurses library. Trick such applications into linking with wide character libraries by means of symlinks and linker scripts. So this is a little script to do that. So it actually creates some extra PC files for wide characters. And then we want to remove some things here and change something up. Finally, make sure that old applications look for Ncurses at build time are still buildable. And that's, I ran the command before here. So let's see here. So here we remove the old lib Ncurses SO, we echo the input command into that file and then link to it. Okay. If desired, install the documentation. Yeah, why not have the documentation? It's always nice to have that. Okay, so there is an extra step to build the ndist without this non-wide, so we can build that instead, but I will not follow those instructions. So let's go on to the next package here. We may do one more package, I believe. Let's unpack Attr and install that too. So here we only need to do configure, and in this configure we want to add the prefix for USR. We want to set the specific bin directory to install to. We want to disable the static libraries, so it will use the dynamic linked libraries. We want to set that the system's configuration directory is /etc that we have talked about earlier, and we also want to set the documentation directory to USR shared doc and this Attr, so that it knows where to put its documentation. So those were quite self-explanatory, and those different flags. we want to make this, of course. It builds a little bit. It has a little bit of a check in it to see that everything passes. 2 tests. Woohoo! Somebody was really excited to build tests. And then we run an install, so we have that installed. And the last thing is the shared library needs to be moved into the lib directory because it was made in the USR lib. So let's do a little bit of a move there and then link it back. So the same goes for this as we did for Ncurses. So now we have built some of the packages and we are actually starting up to build most of the core system libraries because now we have built everything that is required to build different packages, like the compiler and some text handling, some unpackage tool, and so on. And this Attr, even though it was, let's see here, it's a package that contains utilities to administer the extended attributes on file system objects. So that's, I guess, changing flags on files, perhaps. Some of the specific flags on different file system objects. So I have used these, I believe, to set parameters on hard drives. These tools are not often used by hand. It's often that different other tools are calling to these. So maybe you are not required to actually know them by hand. They are called Attr and getFattr and setFattr for different file attributes. So I think I will stop here before we get on and build a lot more of the system packages. So I hope that you found this interesting. This is a long-going series where we build Linux from scratch, and I hope that you learned a little bit more about Linux, a little bit more familiar with using the different environment things in a Linux system and know what they do. And if you like this video, give it a like, share it with your friends and colleagues. If you have any comments, suggestions or questions, leave them down in the comment section down below. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.